going to be walking through how I solved number 4 on the test. This is the problem. It is consider a thin plastic rod bent into a quarter circular arc of radius r with center at the origin as indicated in the figure. The rod carries a uniformly distributed negative charge, negative q, and is located in the xy plane. Answer the following questions to determine the electric field at a point on the z-axis. So for part A, it just wants you to find the vector from the observation location. So you simply take the location of the observation location minus a point on the quarter circle, which gets you this. And then for part B, it wants you to express the charge of one slice in terms of the angular length. And I just had memorized the formula, so I was able to figure out that this is only a fourth of an entire circle. Oh, this is a fourth of an entire circle. And since an entire circle is 2 pi, that means it's only pi over 2. So it's just the negative q over pi over 2. And then I simplified it into just changing q is equal to negative 2q over pi times theta, the change in theta. For part C, it wanted you to find the electric field at the observation location. So for this problem, you use the vector you found in part A, and you have to write out the formula for an electric field, which is this, and instead of q, you have change in q, and you found change in q in part B. So then you also need to find the magnitude of this vector in order to find r hat, and due to trig identities, this and this squared will just turn into r squared. That's obviously z squared, so you just divide this entire vector by r squared plus z squared, and then you simply plug in chug to find the electric field. And I also factored out r squared plus z squared here, so I get r squared plus z squared to 3/2. Otherwise everything else is just plugging in numbers. Then for part D, it wants you to integrate, oh, this isn't focusing. Alright, for part D, I wanted you to integrate the charge distribution to determine the z component of the electric field at the observation location. So for this, it was pretty simple. You took your electric field equation from before, and you just integrate it with respect to theta over 0 to pi over 2, which is the entire circle, because it's only a quarter of the circle. So you just go from 0, which is a point on the far right, to pi over 2, which is 90 degrees. And since you're only integrating theta, you don't have to worry about all this. You just treat it as a constant, like you do when you usually integrate. And you just integrate this, which gives you theta. So it's pi over 2 minus 0 is the value for theta. You can ignore the 0 part, so then easy, you just plug in, for easy, you just plug in pi over 2 for theta. And once again, I simplified. So that's how you do number 4. I thought it was pretty easy.